Hey, what's up, everybody? It's Hutch here, and this is Module 10, Lesson 4. This is going to be our last lesson of this module. Really, the objective is for you to, in this entire module, understand what is a valid sampling method that's fair and unbiased, how to analyze data, interpret data, how to understand the variations in data, and now to be able to look and analyze two different sets of data that are really overlapping and make some inferences about those. Okay, so today's going to be about looking at double box plots and double dot plots and looking at whether they're symmetrical or asymmetrical, which the prefix a just means not, and understanding what we should do to interpret those things. Okay, so let me get the pointer out here. So when we're talking about its distribution, we're talking about just how the numbers are distributed on the graph itself. And so a symmetric, we know what symmetry means. Symmetric distribution means we have a center and we have equal amounts on the right and left side. Okay, that can be true for a dot plot as well. So we have the box plot here, and we have a dot plot here, and you can see why, duh, right? So these are symmetrical, and something just to be aware of. Asymmetrical, meaning not, just means that you're really heavy of data on one side or another. So we're very heavy in data on this right side. And actually, most of the data for this is on the left side. This just means that the range is really big of data here, but the data is really tight together over here as well. Okay, and so when we're interpreting something like this, because here's the center, okay, we have the data is just squished here and very spread out over here. Okay, all right. So anyway, let's go ahead and take a look at the distribution. Okay, it says in this distribution you can see the mean or the average for this data is right here. Okay, and so the question is, well, why is the average here, but the middle or median is way up here? Okay, and so you have to look at, well, imagine if all these zeros were gone. Okay, the mean would probably be up higher, but these zeros, when we're taking into account the mean, are really pulling the average down. Okay, and so that's something to be aware of when you have asymmetrical data. Is the mean gets pulled down by those outliers. Okay, so it's not a really good judge on sort of where the middle of the data is. Okay, and so that's something to be aware of. Okay, when we're looking at box plots, okay, this median is a really great thing to look at, just because that's how you make box plots. Okay, so let's go ahead and take a look at these two dot plots and their distribution. One of the things that I want you to be aware of is when we are analyzing, okay, if we don't see any huge outliers or anything like that, we can use the mean. But if we do see some outliers or some really asymmetrical distribution, the mean isn't going to be good because it's getting drug one way or another because of the data, and the median is going to be a better interpretation of where most of that data is, okay, and where sort of that center is, okay. And so that's what it's sort of saying here is if you select the mean to describe the center, then obviously we can use the mean absolute deviation to describe how the data varies from that mean. Okay, if you select the median, okay, and then in that case we're going to want to use the interquartile range to decide how it varies, because it's going to tell us where each quarter of the data is from that median. Okay, so this is what you would want to highlight. Okay, is this right here? If you select the mean to describe the center, select the mean absolute deviation. Okay, and let's pick a different color here. If you select the median to describe the center, select the IQR or interquartile range. And we've practiced doing that yesterday or in the last lesson, so you should be good to go with that. So let's go ahead and take a look at this. Okay, it says select the appropriate measure of center. So if I'm looking at this and want to identify the measure of center, I notice it's really heavy on one side, and then we have these couple random ones. So when we have what's called asymmetrical, remember, we actually want to use the median instead. So we're going to use the median, okay, to look at the center. And then we are going to use the IQR off of that to sort of see how it's spread from the center. Okay. When we have symmetrical like this, we actually can use either the mean or the median. Okay. And so for this one, we'll go ahead and write either. Okay. So if you like to use the mean on this, you can. Either will work just fine because the median and the mean are going to be the same anyway. Okay. All right, let's go ahead and take a look at the next part of this lesson, which is comparing two populations. So these are just called double box plots or double dot plots, and it allows us over top of each other to look at the data to see how it compares. Okay, and so when we're looking at the data, same as before, okay, if both of the data is symmetric, okay, then you can use the mean or the median, okay, and any of the measures of variation. If they're both asymmetrical, you need to be using the median, and even if just one is symmetrical and one's asymmetrical, you need to use the median, okay, because that's going to better identify where the center is, ignoring some of those outliers, okay. So let's go ahead and take a look at these here. It says use the measure of center and variation to compare the two populations. It says what is the median of the top box plot? So we can see that right there. It's 35. That's the middle piece of data. And the bottom one is at 15. So how do the centers compare? The median of the top one, it is more than twice the median because 15 times 2 is 30. So it's more than twice the median of the bottom. So what's the IQR of the top? Okay, so we have our 40 here is the upper quartile and our 30. So the IQR, the top one, is a range of 10 pieces of data. And the bottom one is 20 and 10 is also 20 minus 10, 10 pieces of data. Okay, so their ranges are very similar. It's sort of just shifted. The upper one is higher than the lower one. So how does the data in the populations vary around the median? It says because the IQRs are the same, the data is very similarly clustered around each median, although the medians are different. Okay, so that's how you can interpret something like that. So let's go ahead and try it out now. We have double dot plots showing the heights in inches for girls and boys in Imani's math class. So it says use the measures of center and variability of this sample to make an inference about the heights of students in her grades at school. Now, it says because they're both symmetrical, meaning you can almost draw a line down the center and see that they're equal on both sides, it allows us to choose whether we want to do the mean and mean absolute deviation or the median and interquartile range. It says for this example, the mean and mean absolute deviation are selected. Find each mean. It's annoying that they're telling us to do this because really the median and the interquartile range would be quicker and easier and still give us the same information. So it's annoying to have to do. Oh, sorry. I guess it's late and I'm getting sleepy. It's annoying to have to do the mean and the mean absolute deviation, but they want us to get experience with doing both. So let's go ahead and do this, and on the next one we'll do the median and interquartile range. All right, so here we go. Find the mean of each one. Okay, so let's go ahead and pull our calculator out and crank through this as fast as we can here. I'll just use the big calculator here for this one. All right, so we're going to do the top one. So we got 60 plus 61 plus 61 plus 61, except not times 61. Oh boy. All right, so 60 plus 61 plus 61 plus 61 equals 243, plus 62 plus 62 plus 62 plus 62. Wow, I'm really messing this up, huh? I feel like you have to start over here. All right, let's do a refresher here. Okay, we got 60 here. 61 times 3 is 183. 62 times 4 is 248. 63 times... Man, it's not typing. 63 times 3 is 189. And then 64. All right, let's go ahead and add all those up. 60 plus 183 plus 248 plus 189 plus 64. There's my total. Divide by how many pieces of data to get the mean. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So divided by 12. All right, so on average, we have 62 is the mean, and I think we probably could figure that out without even doing all that data. But anyway, the girls' mean equals 62. The boys' mean, just to speed things up here, is going to be 66. But you could calculate the same way if you needed. Find the mean absolute deviation for each one. So what's the average distance from the mean? Okay, for each one. So we have a lot of zeros here, first of all. So let's go ahead and clear our board here. So we have 0, 0, 0, 0. We have 1 away, 1 away, 1 away. So this actually is pretty easy. 2 away, 2 away for this one. We have 0, 0, 0, 1 away, 1 away, 2 away, 2 away, and 3 away and 3 away. So let's get the average distance away. So we have 2, 3, 4, 5, 6, 7, 8, 9, 10 divided by 12. The average distance away for girls, the mean absolute deviation is only 0.83 with the 3 repeating. So really not very far away from each other. Let's go ahead and do the boys. We have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 boys were polled. Okay, and so we have an average distance of boys of 1.384, blah, 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 blah. And so let's just do 1.4 with the 4 repeating. All right, so either way, I would say these all have low variability. Okay, they're all within 1-ish from the mean, so there's not too big of a variation in those. Make an inference about the heights of students in Amani's grade at school. I mean, I think we can see when we look at the mean of girls and the mean of boys, mean of girls is 62, mean of boys is 66. If you just find the difference between those, we could say on average the boys are how much taller. So what, 62, so about 4 inches. So we could say on average the boys are about 4 inches taller. Okay, so something like that than the girls. Let's go ahead and take a look at example 2. Now we have the double box plots. Okay, and so let's go ahead and, because we have some asymmetrical Okay, this is symmetrical, right? There's the middle, and it looks very even on both sides. Okay, but if we look at the median for this one has a big range, and this one has a very small range. Okay, and it actually also has this asterisk. So it looks like it actually does have a equal range. It almost looks symmetrical, but they're identifying this asterisk, okay, this outlier here, and that means because the outlier, they chose to use the median to represent this data. Okay, and since they're doing the median, they chose a box plot because it really shows the data well like that. Okay, all right. Let's go ahead and take a look and compare. Okay, so it says find each median. Okay, so these are nice and easy to see. The Rapid Adventures, this is showing the daily participants for 2 different adventure companies. Okay, so Rapid Adventures has 70 participants as the mean, and Whitewater Tours has 50 participants. We can see the median right there. Okay, find the IQR. Those are nice and easy. Okay, so we take the 80 minus the 50. Okay, and so the IQR equals 30. Okay, so that's how spread out the data is in the between the first and third quartile. And then Whitewater Tours, we have 60 and 40. So its IQR is only 20. It's in their quartile range. Okay, so that means it's a lot tighter and closer to that 50 mark than Rapid Adventures. Okay, Rapid Adventures is a little more varied and spread out. Okay, so make an inference about the population of daily participants for the 2 adventure companies. So what could you say? Well, I mean, overall, it looks like the Rapid Adventure tends to have more participants. Okay, their median is higher than Whitewater. The only difference is Whitewater is much more consistent because look how tight their data is. Their IQR is tighter, their overall box plot is tighter. So we can say something like Whitewater is more consistent with visitors, but Rapid Adventure tends to have more visitors overall, something like that. Okay, so that's how you can interpret that. So let's try this one out before we head to the homework. It says the students of a middle school start a blog for their English class, and they contribute to it all year long. This double box plot shows the results for how often 7th and 8th grade students contribute to the blog. Okay, so like overall, just be looking at these 2 box plots and be like, all right, well, which grade devotes more time to the blog? Okay, and so if you're looking, where's most of the data? Well, I mean, you have the 8th grade here. Okay, this is 50% of their data. Okay, the main center part of this group's data, this 50% of data, is down here. Okay, the median is all the way down here, and their median is up here. Okay, and so it gives you some ideas of how you want to interpret the data. Okay, they both have the same minimum, so there's been times where no one contributed. Okay, they both have times where 30 people contributed. But that doesn't really help us. We need to look where most of the clusters of the rest of the data is, and that is really what tells us a lot here. Okay, so it says use the measures of center and variability of these samples to select all the statements that can be inferred about the data. So it says the students in 8th grade posted more blogs more often than students in 7th grade. Okay, and because it's so clustered here and it's higher, you can infer that that's true. Okay, so let's see this. The students in 7th grade posted blogs more often. Well, no, most of their data is clustered in a lower range here. Okay, all right, the amount of variability for 7th graders is greater. Okay, so looking at variability, okay, we have to analyze here the variability from the medians. Okay, so let's go ahead and erase this. Okay, and let's look at the IQR. So that's how we're going to test variability. So we have 25 and 15. That's only 10 apart, right? Okay, and we have a 20 and we have a 5, and that's 15 apart. Okay, so which one has more variability? Well, this has more variability. Okay, so the amount of variability for 7th grade is greater. Yes, that's true. Okay, they're not as consistent. Okay, and then the last one is every student, every student in 8th grade posted more blogs than every student in 7th grade. Well, no, that's definitely not true because, every student in 8th grade posted more blogs than every student in 7th. Well, we can't say every. Okay, the only way to say every is if this entire thing was over here and wasn't overlapping. Okay, since it's overlapping, we can't say that every student blogged more. Okay, and then the last one is, it says 25% of 8th graders posted at least 25 blogs throughout the year. So let's go ahead and clear our little notes here. 25% of 8th graders posted at least 25 blogs. So here's the 25 right here. And we're saying 25% of 8th graders. Well, remember what each section is? Each section is 25%. Okay, so did 25% post at least 25 throughout the year? That would be a yes. Okay, so that's how you'd interpret some things like that. Okay, all right, let's go ahead and to the practice homework. Okay, and let's go ahead and talk through, and then we'll let you try it out. So this shows the weight in pounds of several house cats and small dogs. Compare their centers and variability. What are some inferences you can make about the data? So we want you to just look at that. Notice they're symmetrical, so you can look at it however you want. And when you look at that, what is something you can say? So write a sentence here of something you can say is true about the house cats versus the small dogs. Okay. All right, this double box plot shows the number of calories per serving for various fruits and vegetables. Again, you're just going to look at these and make some inferences. So this is going to be writing a sentence of something that you can identify by looking at those two box and whiskers. Okay. All right. And then number 3 here says this double box plot represents the average number of hours of homework each week for high school students and middle school students. They want you to use the measure of center, which in this case is going to be the medians, right? And the variabilities, which for this one's going to be the IQRs, okay? To select the age group or groups to which each statement applies, okay? So make a check or an X if it's true or not true. So the median is greater in what? Middle school or high school. Okay, and so on. Okay, so go ahead and analyze those and make your check marks. And then the last one is right here, the apply. This shows the number of rainy days for each month in a year for 2 different cities. For which city is it more likely that a random selected month will have 6 or more rainy days? Okay, so see how you interpret that, and we can talk about that the next day. Good luck.